Hello physics students. I want to talk to you for just a few minutes about some basic terms in the scientific description of motion. That has a name. The name is not super important that you remember, but I am going to mention it, and that name is kinematics. So that's what we are studying when we study motion in physics. Oops. Kinematics. Um, there you go. You can forget that word if you wish, although you may see it occasionally here and there, so worth storing it in the back of your mind. Okay, so first thing I want to talk to you about is the importance of measurement. We've already discussed this a little bit in class, but remember that one of the basic skills of a science is important measurement. And so when you make a measurement, we do say that there's something that you need to consider, and that is where you are. So if you make a measurement, we say that you're in a particular reference frame, making the measurement from that reference frame. And so it's the position from which you are making your measurements. As you know, you might see things slightly differently if you're making measurements from different positions. For instance, if I'm looking at the screen this way, I see the left side over here. If somebody were looking at something from a different angle, they might see, or from a different side, they might see the left side as the right side. I think we discussed that. Like when I'm looking at you, I'm saying, oh, this is left, and you're saying, oh, left is over here. That sort of thing. So the reference frame is the position from which a scientist makes measurements. So a scientist needs to designate their reference frame when they're making measurements, and a typical way they do that is by saying, okay, here's the center of a coordinate axis, 0, 0. I'm measuring from here. And then use whatever instruments you need to do that. So I've drawn an axis here, a pair of axes here. Remember that space is three-dimensional, x, y, and z, but we spend most of our time just dealing with the x and the y, the horizontal and the vertical in AP Physics 1. So you don't really need to worry about the z-axis. So I want to point out to you something important about the coordinate axis that you may not have thought about in terms of the real world, and that is it goes left, right? There's a negative x over here, and there's a negative y down here. So that means that if you say 0, 0 is here, it is possible that you could put things at a negative position. So that is an important thing to consider. Now, when we talk about position outside of science class, we're pretty loosey-goosey about it. You might be trying to tell people where your house is, and you'd say something like, well, FHS is here. My house is 2 miles away. Okay, and you're thinking, well, it's 2 miles away to the southeast. When you say 2 miles away, of course, people who are listening to you don't really know where your house is. That's supposed to be a circle, pretty lousy circle, but it'll do for our purposes. When you say 2 miles away, all those people really know about your house is that it could be anywhere on a circle of 2 mile radius with FHS at the center. That's not very precise. It could be useful, but it's not terribly precise. So in physics, we try to be much more precise than that. And that leads us to be a little bit picky about the way we talk about where things are. So let me get rid of this sloppy drawing. Okay, so now I've got my coordinate axis here. I don't really have an object. Let's grab a little object. Just to have something to move around. How about a little red pentagon? No particular reason. So if I center the red pentagon here, you'd say, well, it's at the origin, so it's at position 0, 0. If I move it over here, and I didn't put numbers on here, but let's just assume that these grid marks are each 1 meter. 1, 2, 3, 4. Now I've centered it at positive 5 meters. So you'd say something like x equals positive 5 meters. And then, subsequently, if I moved it again, moved it over here, I don't know where I'm at, but I'm on the negative side. x equals -6 meters. So those designations, positive and negative, with the number, make the position here tell you whether it's left or right of 0. So that's kind of powerful. That's much more useful than just giving a single number with no sign to it. So I want to point out to you that position is always designated with reference to some axes. And if it's positive or negative, that has significance. Now, I made x here the variable because that's pretty much what we do for the first few weeks of kinematics. A little rusty with my writing tablet, sorry. But y is also a variable. Y could be positive or negative, and we could also have something that moved in both the x and the y. So my pentagon could be here, -6, and then I could put it over here and say, okay, it's at -2 and 1, 2, 3, 4, centered on +4. We probably won't do that for a few weeks, so no need to worry about that. Let's just stay confined to the horizontal dimension, and all we're talking about is positive and negative x right now. Okay, so that's position. You do need to give it a positive or negative value. If it's just assumed positive, you don't have to put the plus sign. If it's just written as positive, then that should signify to you that it's to the right of the scientist's origin of their reference frame. Okay, I'm going to put that away, and let's talk about moving. Okay, so now if I put my object here and I move it, I can end up lots of different places. Let's say I end up at 5 again. 1, 2, 3, 4, 5. If I move it straight over here from 0 to 5, then I might write that as x initial equals 0 meters, and x final equals 5 meters. Now, the distance the object moved was 5 meters. The path along which it moved was 5 meters. The center of it changed by 5 meters. So the path length, the actual length it took, was 5 meters. I could have gotten there by a different path. I could have gotten to here by a totally different path. For instance, I could have started at 0, and I could have, could have wiggled it, done all kinds of things, and then ended up here at wherever 5 meters is again. I think it was there. It's not so urgent that it's in the right spot. And that would be a very different path length, but the starting and ending positions would be exactly the same. So there's a difference between path length, or what's sometimes called distance, and displacement. So let's define those two things. That path length would be that actual path, and I don't know what I did, but I'll just draw a squiggly line, something like this, to end up here. Ended up there. That total distance would be the path length. That could be important. We might need that for something. Also, it's really important to know where it ended up and the change that it underwent. That is called the displacement. So if I want to calculate the displacement, it does have a strict mathematical definition, and displacement is designated by delta x or delta y if it's a vertical displacement. But again, we're only working in the horizontal, and that's x final minus x initial. In this case, 5 meters minus 0 meters, what we already knew, 5 meters. Now, if I take my object, and of course I'm not going to calculate the path length, I'd have to figure out the length of the squiggly line that I drew. But you can imagine that, in particular if you're walking, say, the path length is important to you because it takes effort to move every step of the way. But what's actually sometimes more important is where you end up. So now let's consider a couple other things about displacement, and then we'll leave this topic. So now, if I'm at 5 meters and I move here, where was I, -6 meters, I'm going to assume it's there, then my displacement has become negative. Obviously, I moved left. So my displacement would be x final, negative 6 meters, minus x initial, 5 meters. That's negative 11 meters. In this case, that's also the path. Path length is 11 meters. Path length doesn't have a sign. You wouldn't call it negative. That doesn't make sense to have a negative path. But that amount, the magnitude, 11 meters, the magnitude is 11. That is a fancy physics word that means the size of something. And then the sign is, direction is left. I'm really out of practice with this thing. Negative, assumed left when we're talking about x. So the displacement can be negative, and it's always calculated as final minus initial. One last thing, this xi, xf, initial and final, those are not universally used. It is also possible that, let me erase a little bit of stuff here. I'll just write over here. Final could also be written as x, and initial could be written as x with a sub-zero. So if you see that, the sub-zero means at time 0. That's supposed to indicate to you that it's initial, because we assume that we're always resetting our stopwatch to time 0. Don't let that confuse you. A lot of the time I'll use INF because it's a little more obvious. College Board often uses X and X naught, but you'll get lots of practice with those. Thanks for watching. Remember, what one fool can learn, another fool can learn.